My name is Ken Collins. I work at Custom Inc. The title of the talk is actually wrong. I didn't do clickbait. I just kind of got it backwards. It's actually full stack to functions and then back again. So I'm going to tell a story about how we at Custom Inc. are using Lambda, how we started off with, say, full stack applications, what we're doing in our architecture, and basically round tripping that all the way up to Lambda and then back again to how we're using Lambda in a full stack environment. I think if anybody has a question, like if something's really burning, you want to stop and ask something like that, feel free to do so. But hopefully we can also take questions at the end. A little bit about myself. So again, my name is Ken Collins. I go by pretty much meta skills on the internet everywhere. That includes Xbox. If you want to play video games with me, you can find me online. I don't have the one for PS4 yet. If you know the person that's meta skills on PS4, I want my handle back, or I will buy it. I don't want to do real meta skills or anything stupid like that. I'm a staff engineer at Custom Inc. I've been working there for quite a while. I want to tell you a little bit about myself because I feel like if you understand sort of my perspective and where I'm coming from as an engineer, that you can maybe sort of understand some of the decisions we've been making at Custom Inc. And I just don't like to talk about myself, but I like to, say I am a Ruby developer. I head up the Ruby group in the Norfolk and the Hampton Roads area. I love Ruby to death. It's my first programming language, but Ruby was not my first job, right? I used to be a graphic designer. I used to be an account executive at a new media ad agency company. For a while, I was actually a marketing director at an e-commerce company. And I picked up programming about 10 years ago because it was really interesting to me, and I really wanted to be able to solve problems that I just normally delegated out either creatively or technically. And I think I came into Ruby just at the time it was becoming popular, and I've really not lost a love for it. I do other programming languages. I kind of have Stockholm syndrome. If I'm in Node, I like Node. I like callbacks. I like async await. If I'm in iOS, I will do many languages, but Ruby is close to my heart. I've done a lot of open source work. Most notably, I used to do the active record SQL Server adapter for Rails. And even at one time, I got invited to Microsoft to represent. They were basically doing a lot of open source outreach. We all know this now. Like Microsoft is really good with their open source initiatives. And they started a few years back. And they invited the Ruby community, it was me and a guy named Sean Griffin, and the Python community, 2 or 3 of the engineers that represent the Python community, and asking us how they could be better at open source. And it was a real honor to represent the Ruby community. That guy there on the left-hand side, his name is Tobias. I don't know how many database nerds are in here, but SQL Server did not have limit offset support. And that guy right there wrote fetch in SQL Server, which is basically their syntax for limit and offset. And it just made my life so much easier. So I was really giving that guy a good guy to advice. I think he's still there. Oh yeah, everything else was Sean Griffin making everybody else play stupid games on Steam at bars. So after talking pretty much business, everybody just played video games. Let me tell you a little about Custom Inc. So the story I'm going to tell you guys and gals is pretty much one part of Custom Inc. We're a really big company. This is a little bit of my story and how we're working inside of that company. There's different ways that things are going, so don't think this is the only way that Custom Inc. is working. And I want to sort of start that history lesson out with like where we sort of have come from. Custom Inc. is almost going on our 20th year in business. We've been very successful over those years. When I joined, I think I've been there about 7 or 8 years now. But this sort of goes back into the before time, right, and where our architecture started. This is 2007, so this is literally about Rails 1 time. I think we were one of the first companies that actually had Rails out in production at scale. Back then, our architecture was pretty simple. You had a back-end application and you had a front-end application. And that's it, right? Like there were these 2 big sort of ink drops, and that's how we split things up. And for many, many years, that's where we were, right? So after about 10 years, this is kind of where we're at. We're about circa 2017 now. And the list that you're looking at here is sort of indicative of some of the front-end applications. By no means is this fully represented, but I think we're on the GitHub Blood Diamond plan. We may have like literally 500 repos, hundreds of applications. I've lost count. I can't tell you how many apps we have. But this is sort of a good representation of some of the front-end apps and how things sort of broke up over those 10 years. And I wouldn't say really broke up, right? We're not really developing microservices. I'd like to call these domain services. These are really sort of new lines of business, or as we sort of understood where the architectural ley lines of the company were, we built these new applications. And a good one would be sort of the lab, and how we broke off tech services, the catalog, and and things like that. But the back end one spawned off literally hundreds more. I want to call attention to this one. It's called the fundraising app. I'm going back in time again. This was about sort of 2014, and it sort of affected some of my architecture decisions. I believe 2014 was when Lambda was first introduced. I may be wrong on that, but I think it goes all the way back that far. And about that time, microservices were really hot, right? Everybody was like, okay, that's the way to go. We're going to break things up with microservices. And the way the actual fundraising platform started with us was with a company called Booster.com. Back then, I think Custom Ink employee-wise was only about 300 people. Not all those are engineers, most of those are sales service staff. We built Booster at about 4 months, I think. I mean, we just stopped everything. We built the fundraising platform. We made it profitable. We made it a successful company. We spawned it off into a company up in Boston and handed it off. And then I believe that team went to look to sort of re-architect and re-platform the thing based upon microservices. I don't think that went well, if I remember right. I might be representing Jair here. Okay, you were part of that team. That didn't go well, right? So actually engineering for microservices, I wasn't part of that team. I don't think it's really a thing to do. And it certainly hasn't been in Custom Ink's core DNA to go microservices first, right? We sort of established proven lines of business, proven application structures, and then we sort of optimized at that. Fundraising eventually came back into the platform, and it sort of folded back into our main application stack. But I do remember it affected me greatly when I thought back to how that, the team sort of microserviced and platformed that out, and how that wasn't a good story. So we come back to 2017. And what I'd like to do is sort of break out an example of one of the things that we pulled out of the front-end app, specifically our design lab. Our design lab lets you compose sort of text, clip art, fonts, uploads onto products, while you're literally designing on your shirt, our cup, our pants nowadays, and flip-flops too. But the key services behind those are sort of one called Foundry, which handles text, and another one called Clip Art that handles basically all the artwork in that you can search for. Now, in about 2017, we needed to sort of optimize that. We were growing at a point to where the clip art service just couldn't keep up with things, especially the part with the render path. The clip art application is pretty big. It has the management aspect. So there's internal parts of it where we upload and tag and keyword the clip art application. But the render path in the lab, where you're actually, say, resizing the clip art and it rasterizes the SVGs or the EPS files and pulls them back into the browser, was under serious load and needed to be optimized. Back then, engineer named Hunter Madsen, a brilliant kid. This guy was, I think Hunter at the time was maybe 18 or 19. He re-architected the render path in Lambda and Node. And I love Hunter to death. I think he was 19 at the time. He's wise beyond his years. And the story about him, he would say random things like, back in my day, we used to smoke with fire, right? And I'm like, back in your day, that was yesterday, right? He talks like his favorite programming languages predate him 30 years. I have no idea. I think he's reincarnated Linux sysadmin or something like that. But a brilliant, good kid, great human. And he sort of optimized this really pain point we had. It's basically, I think it was a Node 6 Lambda operation that highly optimized and platformed that out. It was a good success story. In fact, we were even written up on the AWS testimonials. Woo! Oh, that's getting good. Try that. Maybe I just fell asleep. Maybe I stepped on the cord. Oh, there it goes. Cool. So I actually thought this was really cool. AWS, I think, even invited Hunter to come speak. They wrote up a nice testimonial about this. I think the biggest thing that I remember from this is that we actually got 90% cost savings from our idle EC2 instances and moving it over to Lambda. It was a huge win for us. And it really sort of affected my perception of Lambda. And I want to kind of go back in time a little bit. This was circa 2014 again. And when people used to talk to me about Lambda, I was very skeptical about it, right? I would think in my head like Lambda calculus, functional programming, and I would think, oh my God, everybody wants to break up our services and they just want to obliterate it and smash it in and make every Rails controller / action a separate function. And this is what the story I was playing out in my head when everybody would talk about Lambda until Hunter had optimized and done that sort of work in the clip art. But this is what I looked like when everybody talked to me about Lambda all the way up in 2017. I just totally did not get it, and it really didn't click for me. But sort of Hunter, he did his work, he proven it out, and the clip art application got this highly optimized path bar in it. And like this would it wouldn't be I would call this our first microservice in 2017 within the custom ink platform. Very, very small part of a very small application, a domain service that got really optimized under AWS Lambda. So I thought, okay, I get it. I want to kind of have fun, right? So now that I'm like this, it's like we're not going to obliterate the front end services, right? The natural evolution of our application structures will break these things out. We'll have separate domain services when they're sort of understood and to be extracted. Then if need be, we will re-platform certain parts of them under AWS Lambda and create microservices when it needs to happen at scale. So, coming from a design background, a lot of the image architecture and stuff that I do for custom ink, it's a lot, but I kind of like to focus on marketing. I like to focus on things that sort of drive business value. I don't just move things to Kubernetes just for the heck of it because that's going to provide value, right? I like to focus on things that actually change a customer experience. And for me, that's a lot of sort of our image architecture. And when I broke these out with the teams and talked about ways that we can sort of optimize things, because we were having certain pain points, and one of them was in our proof service. And basically, after a little bit of time, I took one of our proof services, I broke it up, and I actually made a microservice out of one of it. I took the aspect of, it used to be the proof service would show you your design on the product. You'd see that in an email after you saved your design. I broke that service up so that there was one part of the proof service, all it did was render and rasterize the design. And then I created another service that dealt with the placement and the composition of that design. So it sort of unlocked our architecture so that we could start reusing designs on different things at scale. And with the Lambda service doing the composition and the placement, we can now imagine new experiences that actually, like maybe if you were browsing the catalog, we could put your design on all the products in the catalog, right? And it could spin up hundreds of Lambdas in concurrency, and we just don't have to think about it, right? And at nighttime, they can all go to sleep, and they can all wake back up again, and it's no problem. So I got addicted to the optimization of Lambda and using it in our architecture to create these microservices. And Custom Ink's a great company to do that. After 20 years in business, there is a lot of low-hanging fruit if an engineer were so inclined to just go make something fast, or to go make something that's a pain point after 20 successful years of business that needs to be optimized at a certain point in time. So, mission accomplished. Oh, that's a bigger version of me in my sweet David DeSandro refactor t-shirt. And I think the general idea, I can't see my notes, but the concept here is that, like, okay, we finally figured out how to do microservices. Within Custom Ink, one of the things that I've been working on is sort of improving our DevOps culture. Now, on the slides previously where you saw all the things broken out about 2017 actually marked the time that we did our full lift and shift in the cloud, right? Like we used to run our own colocation facilities. We had servers in closets hidden somewhere in some places, right? 2017, I think, marked the final end of where all those servers were found and everything was moved to the cloud. But that's our lift and shift story into the cloud. We still have all the old chef and configuration management and everything that we did like we were doing things on boxes, but it's just the same thing with EC2 instances. We decided, and I think that's, so this slide, that we needed to sort of improve our DevOps model. Now that we're in the cloud, we want to actually start programming natively inside the cloud. Like it was, like we were never there, and then going there now for the first time. So we've been using Lambda to sort of bridge that guide, right? Like we saw with these microservices how we can get sort of addicted to things like, say, infrastructure as code. How we can, engineers could be more involved with the full deliverability pipeline of the Lambda all the way, not just from the development of it, but actually, helping deploy it out into the AWS ecosystem, dealing with the monitoring of it and things like that. It was sort of our candy for the developers to kind of come down into the WebOps space. But we've also been working to sort of bring the WebOps space back up to the developers, right? The idea is that once we sort of mix these two sides, we're actually just going to change the conversation that we're having, right? We're not going to be talking about, like, here's a Jira ticket to make a bucket for me, right? Like, here's some good architecture decisions on, like, why this bucket is important or how we might use lifecycle events or other things like that, which are, frankly, like conversations we don't have that often. AWS SAM is we also standardize on. Hunter, when he did his first clip art Lambda, was based on serverless, the serverless stack. We sort of re-engineered things and standardized on SAM. I love SAM. It provides a good sort of development environment. And serverless can do the same thing now too, but what we really wanted to do was understand cloud formation and to understand infrastructure as code, and we felt that adopting SAM and getting to cloud formation through SAM, even though SAM is a superset of cloud formation, or is it a subset? I think it's a subset. Subset or super? Super? Okay. Math. I'm self-taught. So anyways, we adopted SAM. It sort of gets us addicted to cloud formation. It gets us addicted to sort of infrastructure as code. And that's with Lambda specifically, but we're using that as part of our cloud adoption. So coming out of 2017 and these sort of successful microservices, we spun up a couple by this time. I think we have 3 or 4 at least good ones, kind of like ClipArt, kind of like the proof composition service. And we're using Lambda as our North Star for infrastructure as code. You can imagine that all the services and all the apps and all the EC2 instances that we have, they're established, right? It's hard to talk about infrastructure as code when you have a lot of legacy systems running off of that, right? So we're just going through the patterns of like saying, if we did infrastructure as code, if we did cloud formation, what does that actually look like, right? It's easy to imagine it with Lambda because that's this new thing. It's self-contained, and depending upon your services, cloud formation is not going to be able to edit an existing resource, right? If you didn't create that resource with cloud formation, you're not going to be able to adjust it or add properties to it, tie in IAM permissions, etc. But we've used cloud formation from SAM's perspective to sort of bridge that gap and get us in there. We've been encouraging certification at Custom Ink. Having come from a background where I'm self-taught, I didn't go to college. I think I was in the 70s, was part of some Montessori school before it was Montessori, right? Like, I didn't even get grades until 7th grade. Like, my wife thinks I just worked off of gold stars for my whole life, right? But like, certification, I definitely do encourage it. And I think the reason that we are encouraging it as well, if you haven't done it yourself or exploring it, is that it's not about memorizing what EC2 instances is this way or that way, because there's literally hundreds of them. It's more about learning about what's available in the AWS ecosystem. And when you move to sort of a cloud-native adoption of both programming and infrastructure, knowing about something is more important than knowing exactly how to do it, right? That's what docs are for. Certification, I think, is a really great way, whether you go for the CCP, the Certified Cloud Practitioner, or maybe all the way up to sort of DevOps Pro, or even the intermediate at the associate. It teaches you, it forces you to learn laterally about something, so that as you're engineering something, you can do what like maybe a Ruby programmer would do, which is to pick a Ruby gem rather than writing that code yourself, right? So when it might be appropriate to use DynamoDB, when might it be appropriate to use S3 or other AWS tools, and there are plenty of them. And then lately here, we've been sort of working on integrating and training leadership teams to help us sort of like train the trainers, right? Because we've got a lot of, maybe near 50 engineers at least now. So we've got a lot of people to bring up. Some are going to stay in the regular, like, all I want to do is just write Ruby apps or Node apps and stuff, and that's fine, right? But we have to have sort of a tier that helps sort of train what we're working on. So we've used Lambda to change that conversation, right? We've got a few of them out there. We're writing more every day. We've got this story from normally sort of full stack Rails applications that come from our legacy past, going back all the way to 2007. And it's just a small part of our stuff. We still have lots of legacy EC2 instances, lots of legacy configuration as management. One of our senior engineers had asked me, he's like, Ken, when we go from each one of these Lambda projects, sure we have SAM there, sure we have a way that we can sort of like, let's say bin convention to do bin bootstrap or bin setup. It's easy for one engineer to go check out one of our Lambda projects and get set up with it and start developing on it. But once you get inside of that Lambda, it's almost like a snowflake at that point. Everyone was different. Everyone maybe has its own way to treat POROs or POJOs, playing on JavaScript objects. They might choose different directories, lib or source. And they're really sort of unique, right? They solve unique problems, but there's very little structure in there, especially if you're a Ruby developer coming from the Rails side of things. So we sort of thought about this for a little while. He simply asked me, how could they have more structure? And I'm like, well, how can we have like mega structure? How can we literally put Rails into a Lambda, right? I was very happy with the Node work that I had done. Like I said, I get Stockholm Syndrome in a language. I grew to love, like when I think Node 08 came out, like you could use async await versus the promise callback hell. Like I loved it, right? But I really wanted to explore how you could get Rails, now that Ruby is, I think in 2018, standardized as one of the runtimes, how could you get Rails into a Lambda? I felt like that would give engineers a good structure to work in if you could do it. And I found out that this is not language specific, right? So the example down below is an application called Zappa, and I think they mainly deal with how to get Python, Django, or like Flask applications inside of Lambdas. The project above is called Jets, and it actually came out prior to Ruby being an actual runtime on AWS Lambda. So if you're the Jets author, if that's what you've written, I'm going to kind of nag on it a little bit, but it's not, I'm not dissing it, right? Like we all have to do open source work, but I want to talk a little bit about why it wasn't right for us. So this is a screenshot of the cloud formation that Jets would create if you asked it to put your Rails app. And I did it for a Rails app, and it was daunting. Like I knew CloudFormation, I knew how these things work, but when I actually looked at what it was doing, I literally just got so confused that I couldn't understand it. Like, and I imagined if I had to make one change to this thing, if I had to say, hey, I wanted the DynamoDB table with this Rails app versus or an S3 bucket, I would have to learn this entire framework to make one change to get the resources or the outputs I need. So I kind of decided this wasn't for us. So I went back to thinking about what Rails applications and what Ruby applications do. And if this is an example of a handler inside of a Ruby, it's pretty much the same thing if it was Node or something else. But you have to respond with a status code, some headers that could be an array. In this case, it's just a hash object and a body, a string. And it occurred to me in my Rails experience, because I've done some open source work, that Rails is actually a rack application. And if you don't know what rack is the HTTP specification at the Ruby layer for dealing with HTTP, basically. So a Rails application is essentially a rack application. And rack applications, they're basically just an object that responds with status code, headers, and a body. It's almost like AWS and HTTP and all got together to agree on this stuff, or it's a standard and it just works. So after following some guides for AWS on how to get Sinatra running, I was like, I'm going to do it. I'm going to write a gem. I'm going to write a new open source gem. The first thing I need is a logo. I called it Lambie. I got some cheesy clip art. That's the first thing I'd done. I used to be a graphic artist. I completely work in a different direction than everybody else. Cheesy logo first. Second, I wrote this one line, right? This one line, and then I wrote the whole gem behind it. The gem's only about 200 lines of code, but basically it takes the event and the handler context that come in through Lambda, convert it into an environment object, which is just a fancy hash, and sends it to rack, waits for rack to respond, and then pushes the array back up, status code, headers, body. And the line of code, like, I didn't write anything, I literally wrote this first, and then figured out how to write the code underneath it afterwards. And it actually worked. It is far simpler than I thought it would be. And I don't want to trivialize it, but and I don't want to dig deep into it. But if you want to learn how Lambie works on the inside and connects rack, I'd be lovely to talk about it. So there is a website for this. That was the fourth thing I did. Cheesy logo, make the website. And the website basically, I always wanted to do an open source project that had a product website. So this was just me wanting to exercise that. But it serves an actual purpose. Most of the way that Lambie works is that it is mainly documentation, right? If you needed to do something different, like I need to have a custom domain name, and I'm working with either API gateway with my Lambda or application load balancers, right? I have documentation for how you would do that, right? How you would set up your CF distro, your cloud front distribution, et cetera, and stuff. And I've got pretty much most of the cases mapped out in documentation. So just a high-level overview of what is Lambie and what it means for your Rails project. If you have a Ruby application, Lambie does not require you to change anything about your Rails application. Now, I'm going to ignore the fact that maybe some of your Rails applications can have, say, database connections, right? And that's another topic to itself. But internally, this project does not require you to do anything different with your Rails application. The benefit of that is that your local development story, even though we use SAM, and SAM gives us a nice sort of local development API, sort of a server, if you will, you don't have to use it, right? Which means you can still use your local Rails server, Puma, WebBrick, whatever that is. Nothing about your local Rails development, all your knowledge has to change at all. All Lambie is changing that HTTP request handler and dealing with a rack adapter, and then basically some conventions and documentation around your CloudFormation. And it really puts the focus on using SAM well, right? How do you write your CloudFormation and what other resources you need? And I've got a lot more I could talk about, like how we do native cloud development. I've got some Lambda projects which are creating S3 buckets locally, like you don't have to stub things out, and it works really well. So the purpose of the reason that we've done this is like we've actually now have Rails applications and AWS Lambda for custom make. One now, right? We're hoping to do more. This is an example of the architecture for the app. This is actually the architecture for the application that we just put into production. The thing I like about this is that I've never really done architecture diagrams before, right? Like I really love AWS, I really like thinking about things, but unless I was sort of forced to actually start doing cloud native development, first with my certification, then with doing projects like this, I would have never known things about like this architecture that I think are really exciting. So for example, the green box on the right-hand side under US East 1, that represents the cloud formation for the SAM template, right? In this case, I wanted to explore because we don't really have regional applications over EC2 instances, right? We pretty much have everything in US East 1. We got some DR stuff in US East 2 that just kind of sits there idle in case something were to happen, which mostly it doesn't, right? But in this case, with this Rails application, and since I was more sort of exploring what AWS offers, I'm like, I'm going to use latency-based routing with Route 53. I've wired up Lambdas now support application load balancers, so I wrote the Lambda gem so that it can actually use application load balancer events. Slightly different than API Gateway. If anybody here at AWS is listening, I'd love to get the 1 megabyte limit changed to 6 megabytes on the requested size. That would be awesome. But in general, like, I'm really proud of this architecture, and this is what we want all of our engineers to start thinking about. Like, not just the Rails application itself and the problem to solve, but how can I do well-architected solutions, such as things like cross-region availability, globally replicated DynamoDB tables, cross-region replicated S3 buckets, and even this Lambda has another Lambda, right? So our first Rails application has another Lambda, and the one on the right-hand side is an image optimizer, which watches for S3 events on the image bucket and runs like libpng or png quant or gz utils and compression stuff like on that. And I thought it was really neat. So we're moving with Lambda. We're using it to start chunking down into that space of where we have things. We are exploring other technologies like Kubernetes. I'm totally like Corey Quinn. I think Kubernetes is the Greek god of spending money. I think maybe we're also looking at Fargate and some other things. But it's my hope that using Lambda for bigger and bigger things, not just functions, but applications, can sort of help you migrate to that, like where you don't have to worry about the infrastructure, but the same thing that Kubernetes promises you, right? Where it has the auto scaling built in. And if you don't know it, under the hood, that's called Firecracker. Firecracker is what drives that for us. So I'm a Firecracker fan, and I will Firecracker as long as I can until I have to really not worry about if we're going to K8s or Fargate. And I think that's it. So cheesy statement first, we are hiring like web ops engineering managers, regular engineering managers, engineers. So if you're curious to talk to me, if you want a custom make cut or anything like that, let me know. And I appreciate you guys letting me talk. Anybody have any questions?
Yeah, so the question I have is, okay, it can sound naive to you. So you said like, you build your whole Rails application, you just run that, right? So one thing I've failed to realize that, when you talk about Rails, we're talking about basically MVC, right? The design pattern that is called as MVC. So what's the point, right? I mean, the whole point of, in my understanding, the whole point of Lambda is to just deal everything on its own, right? As an independent function. Mm-hmm. So how, like, where is Rails in this whole picture? Like,
Rails is
base function is getting Rails as a gem or something like that?
Oh yeah, so good question. So the question was, is how an MVC framework like Rails deal with that? So if you look at this, I have a global variable called app. And the one thing you actually don't see before this, so you would imagine like there would be an app.rb and your CloudFormation would point to app.rb as your handler. App.rb is probably going to be about 10 lines long. The lines that you're not seeing are, it's about 2 lines of code where you instantiate your Rails application and assign it to app. So that's the cool part about that is that as your code executes, you're instantiating the Rails app, putting it into memory. Right? You're not going to do that instantiation every time the handler gets invoked. So as that gets frozen and unfrozen, it's really performant. And let me tell you, I've done some benchmarks on Rails. Like I took our catalog application and I just hacked it up together and I put it inside of Lambie and smoked it, and it did great, right? I think that's important, and I've seen Chris Munns make some provocative tweets lately that actually hint that that is coming drastically down very soon. We'll see.
Okay, I have one more question. So yeah, so you talked about like from full stack you went to functional, you went to web services and you distribute everything in services. So what did you do with the front end? Like because how do you split your front end? I'm talking about like let's say if you're using Angular application, how do you split that whole thing? What framework do you use or what library do you use?
Yeah, so basically the question is how we split up the front end and do we use other frameworks. So the idea is the front end is still the front end, but lots of things came out of it, right? So the catalog came out of it. It used to be that the lab was inside of the front end. The lab now is its own React application in its own repository and deployed in its own manner and sort of glued together with, I think we're using either application load balancers or Varnish in some weird way to route to that path. But it's basically its own React application. But most everything else is just Ruby apps that are tied together using routing on our main domain. So if you go to /products, that would be the catalog.
There's like one component is rendering inside the other component.
No, it's just Rails application. So yeah, nothing fancy.
What is the peak load? Peak load?
Oh. So the question was, what is our average peak load? Or I happen to have one of our web ops engineers here. Ben, do you want to answer? A billion.
I haven't seen peak load yet.
Yeah, I think it would change depending on, like, if you say, what's the peak load of the text rendering path within the clipart application, that would, or the Foundry application that does text, that would be highly different than, say, what the catalog does. Every one of them is going to be different. So I don't know if I have a solid answer for you, but we're doing a lot of business, and it's not trivial.
How about the page views? How many page views in an hour or an hour or whatever?
Oh, it's been a while since I logged in. So the question was how many page views in an hour? For our main site, it's been a while since I logged into Google Analytics and looked, but I really don't know. I would take a guess. I could probably do it here real quick, but millions and millions and millions and millions. I mean, it's huge.
So it's huge.
Yeah.
So
The
how
other
many?
question I had
Oh,
was, going back to you mentioned SAM. SAM is more like a tool for your really laptop or whatever you're using it, really, like a serverless application.
That is one aspect of it. SAM actually stands for the Serverless Application Model. It is a superset of CloudFormation. So basically, SAM is CloudFormation. The SAM CLI gives you some local development tooling, yes, that will sort of mimic API gateway only. It doesn't mimic application load balancers. Yeah, that pull request is still open. So, and it also acts like SAM, the command line interface, also acts as the packaging and deploy. So if you are familiar with the AWS CLI for CloudFormation, SAM can replace two of those CloudFormation commands, specifically the package and the deploy CloudFormation commands.
So you actually interface with a CloudFormation.
Bingo. And then I saw another question over here.
What kind of workloads work well with Lambda, and any examples of workloads you tried did not work, rolled back?
I'm sorry, but
Like any examples of workloads that did not are not applicable to Lambda, and you tried that but didn't work out for you.
yeah, so I think the question you're asking is examples of workloads that are not Lambda.
Yeah, that don't work. That are not appropriate.
Good and bad for them.
Yeah, so some of the things that we haven't moved into yet, like I know it's possible, like especially database connection. So I mentioned the catalog application. The catalog application mainly makes API codes to our merchandise managing system, much like how the design lab does. It was really ideal to explore inside of Lambda, but it actually does have a small MySQL database. If I architected that app nowadays, I actually would have moved that into DynamoDB versus the Aurora MySQL small instance. It's literally only a couple hundred rows. So when I prototyped that in Lambda, I did do a VPC connection because it does make heavy use of Memcache. So I did spin up a Memcache instance. I did have the cold starts for the VPCs. If cold starts with VPCs are an issue for you, whether that's because you're using database connections or other services like Memcache or Redis or things like that, then that's something I think that you should consider if it should be an EC2, Fargate, or something else. But my goal, what I'm thinking is I'm always thinking about where the hockey puck is going to be. I hate sports, but I think it's a good analogy. I think Wayne Gretzky said that, right? So it's like, I'm thinking of where things are going, right? And I'm putting bet and money down that Lambda is going to get bigger and better, and things are going to start to converge. And I would rather put money down on me not having to worry about infrastructure and things like how Fargate solves it.
And one more question, CI/CD pipeline, how do you handle that?
Great question. Right now it's a little janky. So most of our stuff is running on Travis CI. So basically we're using the package and deploy aspects. We created a Lambda deploy user in CloudFormation that basically has the ability to update stacks and very limited permissions. It can't do IAM capabilities or things like that. So right now we're making it so that if your Lambda is first deployed, you're going to need a WebOps admin or somebody that has AWS access. But then after that, updates to the stack are basically handled by Travis and Circle CI. But we'd like to get a lot better than that. I really want to dip in more the code, deploy, pipeline, star, things like that. Yeah.
So, do all your Lambda functions, do they use DynamoDB or do any of them use like RDBMS?
No, some of them do nothing but image processing. A lot of them, Custom Ink has a lot of heavy workloads around image processing, most of that's to sort of keep things protected. Like a good examples of we have contracts with our font foundries, right? So if we were to use SVGs for our fonts in the lab, then that would sort of leak out those licenses. So a lot of our stuff in the lab and rendering tasks are basically just image manipulation. They first started with ImageMagick, but a lot of our image work now is on libvips, which is also supported in Ruby through function FFI interfaces. So libvips is super fast in Ruby. I even think Ruby outperforms libvips and Sharp and Node. And most of our, I think that answers your question, most of our workloads are around like image manipulation. The newer one that I showed the architecture for is really the first one that actually adds DynamoDB from an application perspective.
So one other question. In the traditional Ruby on Rails, there is always like this convention over configuration. A lot of things are sort of automated without needing to configure. So here in Lambda, simple things like handling like client errors, server errors, connection errors. There are a lot of kind of a repeated code, boilerplate code. The little open source that you created, right, Lambda. So does it handle any of those kind of boilerplate code?
Yeah. So the question was if Lambda handles typical convention over configuration and error handling, and I was very surprised. Like I actually did some tests with Lambda, and it just works. So since I interact with it at the HTTP layer, the Rails, like if you have a 500 error, you're going to get the Rails 500 error. If you wire up through Rails conventions a custom 500 page, you're going to get that. You really don't have to think about it. Yeah.
How do you manage secrets?
Great question. So the question was, how do we manage secrets? In the latest project, we're using SSM parameter store. And since we're writing newer Rails applications, Rails 6 and Rails 5.2 and up, we're using encrypted secrets. So basically, we have a master key. That one master key is held in SSM parameter store. Lambda actually has a rake task that can allow you to either call out to SSM parameter store. It's a one line of code. It's in the documentation. You can either call out to SSM parameter store, use a gem called .environment to sort of punch those into the environment, or you can do like what we do, which is basically at the build and the package time, we package up, we make an API call to SSM parameter store, take the environment variables, write them out to a .env file, and then ship that with the package. And I've been really happy with that because you can basically have deterministic deploys that have environment changes, which gives you nice sort of canary and rollback stories as well. Anyone? Yeah. I'll keep talking.
Have you guys tried like the new data API?
Oh, that's a good question. So the question was if we've tried the new data API. For those not familiar with that, Aurora MySQL actually has something that sort of very much reminds me, if you're familiar with Heroku and their Postgres environment, they used to call it PG data clips. And it basically allows you to query Aurora over an HTTP API, thereby bypassing the VPC configuration. And we have not yet, right? Like, so I've been using a gem. I believe it's called AWS Record. It's written by, I don't want to get punished here for not remembering his name. It's the main Ruby guy at AWS that actually wrote the Ruby runtime and does a lot of the open source Ruby gems. for AWS SDKs and whatnot. But it's basically a nice little thin wrapper that mixes into active model and gives you a very familiar interface for dealing with active record style objects, but in dynamic DB. And that's really been most our focus. Right, good call out, right? That's a very, like if you really had to deal with like a legacy MySQL or Aurora cluster, the data API would be an incredibly good solution. Cool. Anybody else? Awesome. Thank you guys so much again for letting me talk.